All right, so in this lecture, we're going to talk about Task.Run, which is a utility method inside the task class. Now, Task.Run is roughly equivalent to calling task.factory.startNew with a bunch of default arguments like no cancellation token, inability to attach child tasks, and the use of the default task scheduler. Now, the call to task.run actually has 8 different overloads, and they support different combinations of the following. So first of all, you have a choice between task and task of t. So if you don't have a return value, you return a task. You use a task. If you do have a return value of type t, then you will get a task of t, and that would be the argument. It's also possible to choose between cancelable and not cancelable task.runs, just in case you want to provide your own cancellation token. But by far the most interesting part of this puzzle is the last part, whether you're providing a synchronous or asynchronous method to be called. So in our case, that is the something definition up above. So you can provide a synchronous or asynchronous delegate or lambda function to be invoked by task.run. And curiously enough, task.run tries to handle both of those cases uniformly. But you're probably wondering, well, hold on, why do we have to have this special handling for synchronous versus asynchronous delegates? So let me try and explain to you why exactly that's necessary. So let's imagine the following invocation. We have var t equals task.factory.startNew. So we start a task, but inside that task, we make an inner task and we return that task. So you have task.factory.startNew, which in and of itself returns a task of t in this case, seeing how we have a return value. But inside the delegate, inside the lambda itself, we also have a task which is being returned. So surprise, surprise, the result of this is a task of a task. So task of task is what the type of the variable t is. Now you can also change that inner lambda to return, for example, 123 instead of just empty curly braces. And in this case, you'll get the t to be of type task of int. So fairly obvious stuff so far. Now, let's imagine that we write the following. And there is a slight change here because now what we're doing is we're calling task.factory.startNew, but we're providing an async lambda in here. So just like ordinary async invocations, ordinary async methods, we are providing an async lambda just by putting the async keyword in front of the lambda. So interestingly enough, even though this lambda looks like it's returning an integer 123, its return type is going to be task of int, and as a result, the type of t is going to be task and task of int, because guess what? We marked the lambda as async, and as a result, its return value, even though it's just an int, it gets kind of promoted or wrapped into a task of int. So the compiler will actually take the delegate, or in our case, the lambda, the compiler will take it, and it will generally just map it to a func of task of int, and as a result the type of t is once again going to be task and task of int, which might not be what we want, because all we want is a task whose return type is that freaking type that we want, the 123. So we actually want a task of int. So we want to somehow remove the extra layer, so to speak. Now for this we have the unwrap method that was introduced in .NET Framework 4. So you have this unwrap method which gives us what we want essentially. So if you have this whole implementation, you could just say .unwrap at the end of it, and as a result that variable t that we're getting is actually going to become a task of int. Now you might be wondering, well, okay, so we have this unwrap method. What does this have to do with task.run? So in actual fact, task.run is just a shortcut. It's a shortcut for calling task.factory.startNew, which fires up the process, and then subsequently calling unwrap on the result. So if you have an async lambda or delegate being passed in, it's going to unwrap it for you. And it works correctly with both regular methods or async methods. So whatever kind of argument you feed into task.run, you're still going to get the correct result. So for example, here I await task.run, I provide an async delegate, and guess what? The type of the result is going to be just an ordinary int, as you would expect, instead of a task of int, for example. So the takeaway from this example is that await, you can think of await as a kind of of language equivalent of unwrapping something. And as a result, you can sort of call await on something in a series. So for example, if you get a task over task, you can simply call await twice. So this example that I'm showing you right here, it's not a typo. I really do have int result equals await task.factory.start new, because what's happening here is I have an async delegate which returns a task of int, and I stick it into a task factory start new. So we get a task of int being returned, and I call await twice, and as a result I get my final value. I get the final integer instead of whatever. So here essentially I am allowed to make a double await, because first of all we take a task of int. The first await gets you a task of int, and the second await coerces it to an ordinary int, which is what we wanted in the first place. So this hopefully explains why Task.Run exists. It basically exists so that you can have uniform treatment of both ordinary delegates and lambdas, as well as asynchronous delegates and lambdas, and they would sort of yield you similar results.